All right, welcome MAP folks to some review videos here. This one's chapter 1 on Trig. The way these videos will go is I sort of show all the topics that we covered during those chapters and then a couple of typical examples that you might be asked for on the exam. So in Trig, it was basically a review of grade 10 and grade 11 Trig, but the new part was this stuff about obtuse angles, right? If we have an obtuse angle and a triangle, how do we handle what we get out of our calculator? That was maybe the new stuff. And this example 1 sort of shows us which of these are negative. Well, all of these are obtuse angles. Remember, obtuse angles are more than 90. We could just jam these into a calculator and find out, well, that's positive, that's negative, and that's negative. But why is that the case? Well, and this will come up again in the next example. When it's an acute angle, if I were to put the angle, so this one's a 30-degree angle you see here. Let me see if I can, no, I can't. If we just look at this angle, this is in the first quadrant on the XY grid. Everything's positive. The adjacent side's positive, the opposite side's positive, and then all of the trig ratios, sine, cos, and tan, are all positive. If I take the exact same shaped triangle, right, and I put it in the second quadrant, that's a 30-degree angle, then this would be an obtuse angle. This angle represents an angle of 150 degrees. Well, why is it that the cosine is negative then? Well, remember, the cosine is the adjacent side over the, it's SOHCAHTOA, right? Adjacent side over the hypotenuse. Adjacent side is this one, but since it's to the left, this side is negative, right? That's a negative value. Adjacent over hypotenuse is negative, and the same thing as the tangent is opposite over adjacent. The tangent is negative for an obtuse angle as well. And so, I mean, whether we use our calculator or not doesn't matter, but this is going to come in handy in the next example. The idea, since the sine of a obtuse angle is positive, this leads to a problem. State two angles so that sine x is 0.245. So, I mean, how we normally do these is we just jam them into a calculator, right? 0.245. And this might be, you know, when we're solving a triangle or something like that, we know to get rid of the sine, we do the sine minus 1 business. Put that into a calculator. Oops. A little bit shaky this morning. And that's 14 degrees, right? Except for, the problem is, if that's 14 degrees, there's another angle, an obtuse angle, that would give us the sine being 0.245, since the sine of an obtuse angle is positive. So how we handle this is by saying, you know, if x is obtuse, we could have a second case. X could be 180 is a straight line minus and that was kind of the new thing in Trig in grade 12, right? That we have these two possible angles, 14 and 166, and we just get one from our calculator, normal style, from grade 10, and the second one by subtracting it from 180, knowing that there are two angles where the sine is positive. Would we ever have to do this if it was cosine? No, we don't have to do that. All right, so other typical examples, solving triangles, right? Solving sides and angles in triangles. This is a right angle triangle, so I'm going to use SOHCAHTOA. Right. From the angle I'm given, from this angle, what sides have I got? Well, across from the 90 degrees is the hypotenuse, right? That's the hypotenuse. And through the triangle is the opposite side. So which one am I going to use? I'm going to use the sine. I got the sine of 25 degrees is equal to 12 over x. And now I got to solve for x. How do I do that? I cross multiply. And then divide. Oops, that's not a very good 12. Let's make that 12 look better. 12 divided by the sine of 25. And you jam that into a calculator, and you should get around...
Mr. Moore, Moore, call extension 235. Mr. Moore, call extension 235.
Apparently somebody wants to talk to Mr. Moore. About 28.4 centimeters, no problem. When we don't have a right angle triangle, remember it's a little more complicated. We have a decision to make, and the decision is sine law or cos law, right?
Miss Calhoun, by the office, please.
And someone wants to talk to Miss Calhoun too. Notice what we've got here is an angle side pair. Right? There's an angle side pair, and that means when we have an angle side pair, that's the sine law. That decision-making process, like this statement, by all means, you could write on your formula sheet. You couldn't write down the examples, but you could write the like hints to yourself about when to use the sine law or not. So I want to find angle A. I'm going to put it first. Remember, there's actually two forms of the sine law, and I'm going to use the one with the angle on top because that's what we want to find. Sine of 22 degrees over 2.1 kilometers. And how we solve these, remember, is cross multiply. 2.1 gets multiplied up here. And actually, we kind of learned shortcuts there, right? We don't have to multiply by the 2.1 because it's gonna go away again. We got to divide to get the sine A alone, and then we're going to do the minus, the sine minus 1, right? The inverse sine. So I get that, put this whole thing into my calculator, and I get 0.6776. Inverse sine of that, 0.6776. And I get 43 degrees. About. There's a problem though. That's not 43 degrees. That's an obtuse angle. And this is this business that we were talking about before. Whenever we're dealing with sine, we've got to be careful that it's not the obtuse case. So, and that's this one. This triangle is got an obtuse angle. So I got to say A is obtuse. How do I get it then? The calculator lied to me, right? They never gave me the obtuse angle. They'll always give you the one that's less than 90. But I can get it by going 180 minus that, and then I'm done. And that's the only real spot where we'll have to deal with this positive, negative, obtuse angle business is when it shows up in a triangle like this. So beware of that. That's it for trig. Next one, next video, chapter 2 and 3. No, chapter 2 is on perimeter and area and volume and all that business.